Lecture 5, Predicting Quality in Healthcare, Application of Logistic Regression. So this is part 4, the last part of recordings for lecture 5. The final step in building any model is evaluation of the model. So how we are going to assess the performance of the built model. So here we are going to consider two methods of AUC and accuracy. Okay. The AUC measure is the area under the ROC curve. Okay, so when we have the ROC, just take the area under the ROC curve. And so, for example, in this example, the AUC is 0.775. So how we interpret this number? Given a random positive and negative, so here we're talking about the outcome. As you remember, the outcome for our dependent variable was 1 and 0. So here we can say one class is positive and the other class is negative, for example. Okay, so given a random positive and negative, or 1 or and 0, the value of the outcome, proportion of the time you guess which is which correctly. So yeah, I mean, what's the chance, what's the probability to predict correctly? So here 0.775, let's say 0.77, that means in 77% of the times our model predicts correctly. If it's negative, the model predicts negative, I mean 0. If it's positive, in our example y equals 1, poor quality, then with 77% of chance, this model will predict that outcome correctly. Okay. What's the best value for AUC? If you remember, we saw that the perfect point on the ROC curve is just the top left corner, right? Somewhere around here. So if we have an ROC like this, which means this refers actually to perfect situation, right? So by having that, the area under ROC would be 1, right? The AUC here would be 1. So the AUC, the maximum value would be 1. So AUC could be any number between 0 to 1, right? And so by having our AUC value, if it's so close to 1, then we have a very good model. And if it's so close to 0, then we are close to the worst case, actually, the worst possible case. So, but if we have a baseline method, and then for that baseline, we can calculate the AUC, and then we can compare our AUC regarding of our ROC curve with the baseline and the perfect situation. So yeah, between these two limits, I mean the perfect situation 1 and the AUC of the baseline, we'll see how is the performance of our model. Okay. Since we have two outcomes for our dependent variable, negative, positive, or let's say 0, 1, or poor and good, then we can say if we randomly select a class for any patient, then with 50% chance we may and classify that patient in the right class, right? So in this case, we can say the minimum could be 0.5, just a random guessing, right? Yeah, so we can say the baseline method here would be just random guessing. So AUC would be here 0.5. So the AUC of our ROC curve, our model, should be a number between 0.5 and 1. Okay, so based on that, we'll see how our model is performing against the baseline method. Okay. The second measure here for evaluating the performance of the model is calculating the accuracy. So in accuracy, we can consider the true predictions, so which will be true negative and true positive, right? So we are correctly predicting the outcome. So if we add up the true negatives and true positives and then divide this by the number of observations, then we can have a measure for the accuracy of our model, right? For example, in our data set, if we set the threshold to be 0.5, then for 80 patients, we are predicting correctly. So, and since we have 99 observations here in the training data set, in the training data set, we have 99 patients or observations. So 80 divided by 99, so we have the accuracy of 80.8%. So is this good? Let's see. Let's see what's the accuracy of the baseline method, and then based on that, we'll see if this accuracy is good or not. Okay. We talked about the baseline method, and random guess could be a baseline method here, right? But here we can have a better baseline method, I mean better than random guessing. For example, we can consider the most common outcome. Okay, so in our data set, we see that 98 patients actually received good care, and 33 patients actually received poor care. So the most common, I mean the most likely outcome here is being good for the quality of the healthcare. So because of that, we can predict good care for any patient. So that could be our baseline method. I mean, predicting good care for any patient. So if we consider this baseline instead of random guess, then the accuracy of our baseline here becomes 74.8%, because since we have 98 actually good cares among 131 patients, so the accuracy of our standard baseline method here would be 74.8%. So the accuracy of our model was 80.1%. So yeah, in terms of the accuracy, our model actually is beating the standard baseline method here. Okay. After finalizing our model by evaluating the performance, and after making sure that we have a good model for prediction, now we can apply the model on the out of sample data. So here we have segmented our data set to be in training and test data set, and our test data set includes 32 patients. Okay, so now we apply the BELF model to predict the outcome of these 32 patients. So if we consider the threshold value of 0.5 and apply the model for the patients in the test data set, so here we have this confusion matrix here. Okay, and as you see here, we have 23 here, 3 here, the correctly predictions. So if we calculate the accuracy of the model in the out of sample data, so we have 26 divided by 32, and it becomes 81.3%. So as you see here, the accuracy of the model in the out of sample data or the test data is even better than the training data set. Okay. So in conclusion, we developed a logistic regression model based on the opinion of the experts on rating the quality of healthcare for 131 patients in our data set, and this model predicts accurately the outcome for the health for the quality of healthcare. Okay, so in practice, when we apply a logistic regression model and we have the probabilities obtained by the logistic regression model, so maybe we don't need to consider a threshold here and classify any patient to be in one of the two classes, I mean good care or poor care. We just can consider the probability, and based on that probability we can prioritize patients for intervention. Okay, so yeah, we can definitely utilize the probabilities of the logistic regression model like this in the real world. Okay, and also the electronic medical records could be used in the future. Okay, so at the end, let's see what are the competitive edge of using the models. So for our case, assessing the quality of healthcare, we know that we can use experts, right? But whenever we have small amounts of data and information, so it is applicable. We can consider some experts and they can do this job. But if we have a large set of data and information and a large number of patients, so in that case, it's not efficient to use experts. Of course, we can hire more experts and spend a lot of time and cost to do this job, but definitely it's not efficient. So here it's more efficient to use the models. But here we're not talking about replacing the expert judgment by the models. So still we need to have the experts. So experts can help to refine and adjust the model in long term by seeing the performance and the cases. So by having the experts beside the model, we can improve the performance of the model in long term. Okay, and also we can use the models to integrate the assessment of many experts. So if we have many experts and each expert is providing a judgment, an assessment, so we can integrate those opinions by having a model in an unbiased and unemotional process. Okay, so yeah, as you see here, we are not going to replace the experts by the models, but we need to have the models as supportive tools beside the experts. Okay, thank you.